the position of a particle, so this is going to be one of those position, velocity, acceleration problems. The position of a particle is given by d of t equals this. Find the maximum value of velocity on the closed interval from 0 to 6. So again, think to yourself, is this an absolute maximum minimum kind of problem, or is it a relative minimum? Are they talking about how does the maximum compare to the points around it, or is it an absolute maximum? This is an absolute maximum, even though it doesn't say it. It gives a closed interval, and it says the maximum value, not like the relative or local minimums. The maximum value just means what's the highest value. So we're going to be doing the candidates test. And to do that, remember, we're going to come up with our list of candidates that we're going to find the y value for, and whichever one has the highest y value, that's that. Now, what is the function we're finding the maximum of? Well, we're finding the maximum value of the velocity. So we're going to be finding v of t values, right? And we know our x values, or in this case, I guess they're t values. The times that are the endpoints are 0 and 6. But we also need the critical values. But be very, very careful here about what we're finding the critical values of. Try to find them on their own. On your own, what are the critical values? And the critical values are when is the derivative of velocity equal to 0, not the derivative of position. So we're going to actually have to take two derivatives here. Let's see how this goes. So the velocity is equal to the derivative of position. So 6t squared minus 24t plus 18. Okay, and this is the thing we're going to be plugging in our candidates to. We're going to plug in 0, we're going to plug in 6 to see what the maximum velocity might be. It might be 0, it might be at 6, or it might be at the critical values of velocity. The critical values are where the derivative of velocity are 0. So velocity, the derivative of it is 12t minus 24. And we could write that this is the acceleration, but we don't need to. So where is this equal to 0? So 12t equals 24, t equals 2. T equals 2 is in between 0 and 6, so that is one of the values we need to check. So it's either going to be at 0, 6, or 2. Let's find the value. When we plug in 0 here, we get 1. We don't need a calculator for this. When we plug in 6, 6 cubed is 216. 2 times 216 minus 12 times, maybe we should have used a calculator, 18 times 6 plus 1. So we're finding v of 6 here. Oh, what is wrong about this? What am I doing wrong? Hopefully we noticed that I was plugging in into d of t, but we're finding what is the velocity at each of these times. So we should be plugging in 6 here. So 6 times 6 squared, we're doing v of 6, minus 24 times 6 plus 18. Yikes. 216 minus, oh, and that's my answer up here was wrong too. This 1 should have been 18. It's v of 0, not the distance. All right, 216 minus, what is 24 times 6? 24 times 6 is 144 plus 18. So this is 162, 216 minus 162, 54? No, that seems right, 54, okay. And how about at 2? V of 2 is 24 minus 48 plus 18. And so I believe, unless I did something wrong, which I very well may have, I believe that the maximum value of the velocity was 54. Okay, 54 was the maximum value of the velocity. Okay, we need a calculator on this one, so get your calculator out, pause it if you need to. And here it tells us the derivatives. These are the slopes. And it's not a closed interval. And so we won't be looking for, it's not less than or equal to. Remember, on an open interval, you're never finding the absolute maximum. It has a local maximum when x is, okay, so we need to be finding a local maximum, and that is where f prime changes from positive to negative. Hopefully you're feeling good about that, because when the slopes change from positive to negative, it'll be higher than the points around it. So it gives us the derivative. We just need to see where this derivative changes from positive to negative. Go ahead and find it. Which one of these points is where it changes from positive to negative? You need a calculator. And hopefully you recognize that all you have to do is graph and look for where it changes from positive to negative. Cosine of x. We're going to graph this, and I'm going to change the window to be from 0 to 4, because that's the domain they gave me. And since I'm just seeing if it goes from positive to negative, I'm going to put in like -2 to 2. That'll be good enough. So here, the derivative is changing from negative to positive. The derivative values are negative. Now the derivative values are positive. This is a graph of the derivative. Here, the derivative values are positive, and now they're negative. So I want this 0. I could put y equals 0 and find the intersection, or I could press second calc and use the 0 button. When you use the 0 button, you have to go to the left. You have to put 1 to the left of where your 0 is. So this is to the left. 1 to the right. So like, I don't know, 3.8 is going to be good enough. And then it'll find the one in between. So 3.4. And I guess I could have just probably estimated that 3.4 was the answer just by looking at this. It's further to the left than halfway between 3 and 4. So at x equals 3.4, there's a local maximum because f prime changed from positive to negative. Notice, I think some kids will answer like where this has a maximum. That's not what we're looking for. We're looking for where f has a maximum, which is when the slopes are changing from positive to negative. This takes a little while to get used to, but then we get good at it. Okay, at what value of x does f have a relative minimum? This is not a graph of f. This is a graph of f prime. Be careful. Where does f have a relative minimum? And you should be translating. F has a relative minimum when f prime changes from negative to positive. That way the slopes change from negative to positive and we end up with a minimum. So that happens right here. The slopes are changing, the f prime is changing from negative to positive. It's crossing the x-axis. It crosses the critical value here. So let's answer our question. F has a relative or local min at x equals 1 because f prime changes from negative to positive. Okay. If for all x, f prime is equal to this, we've got an f prime. So these are the slopes. It's giving us the slopes. It follows that f has, it's talking about f, relative minimums. Okay. So to find the relative minimums, we're going to want to see relative minimums, relative maximums, all these things can be done from a sign chart. We need to make a sign chart. So make your own sign chart and try to answer which one of these it is. So f prime, what goes in our sign chart is the critical value, so x equals 2 and x equals 1. We need to make sure we put 1 first. We have to go in order from smallest to biggest. Those are the two critical values. And if I pick a point to the left of 1, like 0, I'll get 0 minus 2 is negative, but negative to the 4th power is a positive. I'll get a positive times 0 minus 1 is a negative to the 3rd power is a negative. So a positive times a negative is a negative. Now, I'm going to use a shortcut and just say I know this one will be positive and this one will be positive without testing it. And the way I know that is because this is an odd multiplicity, and so it will change signs, but this one is an even power, and so it won't change signs there. If you want, you can try a number between these and verify that for yourselves, but I can already tell that. So is there a relative minimum at x equals 1? Well, f prime changes from negative to positive, and so there will be a relative minimum, and that's going to be the right answer. If you want to verify the other ones aren't correct, you can go ahead and do that. But go ahead and do that for yourself. Ooh, I like the phrasing of this. If f of x equals x squared e to the x, determine the sum of the critical values. Go ahead and do that. So the critical values are, of course, where f prime equals 0. That's our translation we should be doing in our head. And so we got to find the derivative. And to find the derivative here, we need to do the product rule. And it's the derivative of the first times the second left alone. It's a product because these are just next to each other, so they're multiplying. Plus, we leave the first alone times the derivative of the second, which is also e to the x. And we need to see where this is 0. And this goes back to our pre-calculus way of solving. We need to factor. We need to factor out a common factor. They both have an e to the x. They also both have an x. And so that's what we're going to factor out. We're going to factor out x, oh, sorry, that's ugly, x e to the x times what's left over. X e to the x times 2 and x e to the x times x. So when this distributes, this gives us each of these. And so I can see that my critical values are when x equals 0. E to the x is negative, never equal to 0. And so there's no values of x that can make this 0. And this one will be x is negative 2. And so our critical values, when we sum them, let's make sure we've actually answered the question. The sum of this critical values is negative 2. 0 plus negative 2 is negative 2. So I hope you guys are good at factoring stuff like this from pre-calculus, but I am not sure what you guys did. So normally I would be having more conversations with Miss Lay, but this is a weird year. What is the absolute maximum on the interval from -1 to 1? Go ahead and find that on your own, and we'll do the justification later. So absolute maximum, you should be thinking candidates. We're looking for the maximum of f of x, so what are the different y values? 2 of the values we know we need to check are -1 and 1. We also need to check any critical values. 0 is between -1 and 1, so we need to check that one. We already found the critical values up above. -2 is not inside this range, and so we don't need to check it. So let's try each of these values and plug it into f of x. So f of -1. -1 squared is 1, and e to the -1 is 1 over e. So 1 times 1 over e, so 1 over e. F of 1, 1 squared is 1, e to the 1 is just e. So this is e. And when x is 0, we get 0 times e to the 0, so 0 times 1 is 0. So which one of these is bigger? Well, e, you need to know, is about 2.7, and so 1 over e is 1 divided by 2.7, and this one is bigger. So the absolute maximum value is e. So f has an absolute max of e by the candidates test. Again, make sure you're reading the question carefully. If it had said where is the absolute maximum value, we would just say it's at x equals 1. But if it says what is the absolute maximum, that's asking what the value is. All right, guys, we have a quiz coming up next class on all this first derivative stuff. Make sure you're ready for it. This is a really important topic. It's a huge, like you can almost pass the AP exam just with the stuff in this unit. I hope you have a good rest of your day and good weekend, and I will see you later.